And there we're in presentation. Perfect. Take it away.
Okay. Well, hello, Northeast Ohio. My name is Kelly Haws. I'm the GIS manager at LJB Engineering. Started on the wrong. There we go. So today my team, who consists of James Bell, Ivan Griffin, and Lucas Hershberger, we're going to talk about mapping the invisible and planning for the future. So the agenda for our presentation, I'm going to talk a little bit about the background about LJB Engineering and myself, and discuss the GIS turnkey solution that we offer our clients. Then Ivan will take it over and talk about utility network, how we clean up the data. James will then talk about data collection and updating data. And then Lucas will finish things off by talking about application development. So a little bit about LJB. We've been around for a little under 60 years, and we've been primarily an engineering firm for structural engineering, transportation, safety, but we also obviously offer geospatial services, drones, LiDAR, surveying. So what's unique about the GIS department here at LJB, we not only have external clients, a lot of municipalities that we help, we also offer services internally. So all of the engineering departments use GIS in some aspect as far as data collection forms, inspection forms. So we kind of help everybody out. So our office locations, we've got quite a few, but primarily in Ohio, Texas, and North Carolina. So our headquarters are in Dayton, Ohio, which is where Ivan and I are stationed. But James and Lucas are up in our Cleveland, Ohio office. So we are present in the Northeast Ohio area. And we also have some clients up that way too. And before I get started, a little bit about myself. I've been here at LJB a little over 2 years now, but prior to coming here, I was a GIS administrator for local government in the sewer and water department. So I understand everybody's struggles, the different types of personalities within local government. And prior to that, I was at Electric Co-op in Kentucky. So my entire career has pretty much been in utilities, which is how my team and I came up with the idea of the GIS turnkey solution. So basically what I want to talk today is how to get the most out of your data, because everybody focuses on getting great data, but then what? It's just, how do we keep the GIS evolving? So this is where the GIS turnkey solution comes in. So these are the steps, and this is usually a 1 to 2 year process, depending on the size of the city, government, county, and the number of assets. So it just depends, but it is a lengthy process because it takes time to get everything going. And we like to do discovery meetings. Then we create a database. We'll collect data, digitize assets, develop a strategic roadmap for our clients, create web apps, go live saying, hey, starting today, this is the new processes that we're doing. And then we also provide our clients ongoing support. So I'm going to touch on some things that make our services a little unique compared to other people. So first, when we get a contract to help a utility, a city, clean up their database, get a new database going, we want to hold discovery meetings. So this is where we come on site with the client and meet with all key stakeholders. So when I talk about key stakeholders, I'm not just talking city management, public works directors. Yes, I do want to meet with those people, but also I want to meet with engineering. How does engineering use it on a day-to-day basis? What information do they need for writing grants? How do the frontline workers in field operations use the GIS? I want to sit down and really create relationships with these people and to determine what would help them on their day-to-day life with GIS. Because, they're the ones in the middle of the night in January in a ditch with a water main break. So what are some things that could really help them during those situations? How does customer service use it? How do inspectors use it? How does upper management use it? So this is really where we build relationships with those people, because how many of us have built an application that we know is great and it would be so useful, but people refuse to use it? So this is where we like to take that time to build those relationships and get their buy-in at the beginning of it so they use the GIS. So, and something else that we provide our clients is a 5-year strategic roadmap. So the first graphic that I had showed about the GIS turnkey solution, this is presented in the middle of the project. So these are ideas that we gather from listening to everybody talk, in the discovery meetings. During this process, we hold at least minimal monthly progress meetings. So I can still listen to everybody's, what they like, what they don't like, get some ideas from things that are being said, and then create a strategic roadmap. So, rolling out an asset management program, a lead line inspection form, just, anything that we think would help progress the GIS, keep it growing so it doesn't become stagnant and is not a useful tool for people. We want it to keep growing. So we do this in the middle of the GIS turnkey solution because it gives municipalities a chance to get this on budget, get it in the budget year, and to tweak it. So if they say, hey, I know that we talked about doing asset management program year 3, but things that have been happening, we need to bump that up to year 2. So we can tweak it a little bit. And this is an evolving document because, Esri rolls out things where they say, hey, we're deprecating web app builder, something that everybody's been using for the last 10 years. So we have to roll that into the strategic roadmap to say, hey, by 2024, we need to get everything converted to Experience Builder. So it is an ongoing document. And so once we send the deliverable, say, hey, here's great geo database, you've got great data, we provide ongoing support. So when we give that deliverable, we come back on site with the client and do training, because it's easy for me to sit here on Teams, say, hey, this is how you do it, or sit in a conference room. It's easy, but then once you're out there by yourself holding an iPad, you forget things. So this is where we go out with our clients, field crews in the field, sit with engineering and really, sit them down, have them walk through the process, and we help them along the way. And we provide ongoing support, not just with the GIS teams, but if their field crews want to call, customer service wants to call because they have a question, we're here. GIS teams can bounce ideas off of us or say, hey, do you have experience with this type of inspection form? And we're there to help you guys along the way. So we also offer standard operating procedures because we all know that GIS gets blamed for a lot that we aren't exactly responsible for. So, procedures such as what happens when as-builts come in, who's responsible for it, where does it go? So to help eliminate as-built sitting on somebody's desk and not getting turned into the GIS to update. So we also always provide best practice documents, how to use all the applications inspection forms. So we're there along the way and to help with support afterwards. So that is pretty much the GIS turnkey solution in a nutshell. So I'm going to pass it on to Ivan, who's going to talk about the utility network.
Thank you, Kelly. My name is Ivan Griffin, and I'll talk to you guys about utility network and geometric network today. So utility network is a framework that manages utility services. It includes the physical infrastructure, data, and workflows needed for efficient operations. It provides a complete view of utility assets and their relationships. The previous version of utility network is called the geometric network. And it's used to represent and analyze the connectivity and flow of network features, particularly utilities. It is a specialized network data model that focuses on spatial relationships and connectivity between features. Next slide, please. So how do they differ? A geometric network and a utility network are both network models used in GIS to represent and analyze spatial relationships. However, there's some key differences between the two. First is functionality. A geometric network primarily focuses on representing and analyzing connectivity and spatial relationships between features, such as roads, rivers, and pipelines. It is typically used for network analysis tasks like routing, tracing, and flow modeling. On the other hand, a utility network is designed specifically for modeling and managing utility infrastructure, such as water, gas, or electric networks. It not only captures the spatial relationships, but also incorporates advanced functionality for modeling utility-specific behaviors, rules, and operations. In a geometric network, topology is maintained explicitly using connectivity rules. It ensures that features are correctly connected and facilitates network analysis. Topology in a geometric network is typically based on nodes, edges, and connectivity rules. However, in a utility network, topology is maintained implicitly using a connectivity model. It represents the connectivity and behavior of utility network elements, such as valves, pipes, and manholes, using a combination of geometric relationships and attributes. The utility network's connectivity model allows for more flexible representation of complex utility networks. So in summary, a geometric network focuses on spatial connectivity and network analysis, while a utility network is a specialized model designed for modeling and managing specifically utility infrastructure with advanced functionality and multi-domain support. Next slide, please, Kelly. So what are the benefits of a utility network? Comprehensive asset management. A utility network allows cities to have a centralized and comprehensive view of their utility assets, including pipes, cables, valves, transformers, and more. It offers enhanced data analysis. By converting data into utility network, cities can perform advanced spatial and network analysis. They can analyze the relationships between assets, assess the impact of changes of failures, identify vulnerabilities, and optimize network performance, and make data-driven decisions. It offers improved operational efficiency. A utility network facilitates streamlined workflows and efficient operations. It provides tools for asset tracking, work order management, and resource allocation. By optimizing workflows and reducing manual processes, cities can enhance productivity and minimize operational costs. With a utility network, you get better emergency response and outage management. With a utility network, cities can quickly identify affected areas during outages or emergencies. They can trace the network, pinpoint the location of failures, and dispatch resources more effectively. This improves response times, minimizes service disruptions, and enhances public safety. It allows for more seamless future planning and growth. Converting your data into a utility network provides a foundation for long-term planning and infrastructure growth. It enables cities to model and simulate different scenarios, evaluate capacity requirements, and plan for future expansions, and support sustainable development. It offers interoperability and collaboration. So utility network promotes interoperability and data sharing between different departments and stakeholders. It facilitates collaboration across utility operations, urban planning, public works, and other city functions, fostering coordinated decision-making, enhancing overall efficiency. So in summary, when converting existing data into utility network, it empowers cities with comprehensive asset management, data analysis, operational efficiency, emergency response capabilities, real-time monitoring, future planning, and collaboration. It helps cities optimize their utility services, improve resilience, and deliver better outcomes for their communities. Next slide, please. So a utility network, as discussed on the previous slide, has a fully functioning utility network offers a host of features that end users will find helpful. One such feature is the network trace analysis. Network trace analysis allows the user to examine the behavior and characteristics of a utility network by simulating resource flow. It involves identifying network paths, connectivity, and properties to understand network operations and solve utility-specific problems. Utility networks support various trace types, including upstream, downstream, subnetwork, and isolation traces. Traces can be customized with starting points, barriers, and filters. Trace results provide information on traced assets and a visual understanding of your utility network's behavior. Network trace analysis can be used for identifying connectivity issues and determining affected service areas. In the picture on the left in the presentation, a user has identified an area of concern, whether that be a main break or a section of water main that is being replaced. By performing an upstream and downstream trace analysis, the user can identify water utility assets and customers that are affected by the concerning event, depicted in yellow in the picture on the right. Next slide, please. So how do we gather accurate data for a utility network when we don't have accurate data or accurate existing data? So if we have missing data, we can overcome this by trying to find historic documents that are commonly used for mapping utility infrastructure in cities. These include as-built plans, which everybody is familiar with, maintenance and operation records. Organizations maintain records of utility maintenance and repairs. These records may include notes, diagrams, and photographs documenting the location and condition of your utility assets. There's also historical records from public agencies, such as municipal departments. They may hold archival records related to your utility installations and maintenance. These records can include correspondence, permits, construction contracts, and inspection reports that shed light on the historical development and configuration of utility systems. It is important to note, however, that the availability and reliability of these historic documents can vary depending on age, accessibility, and preservation practices of each city or county of your organization. And finally, institutional knowledge. Institutional knowledge is crucial for locating utilities because it encompasses the collective experience and information within an organization regarding the infrastructure, maps, and historical data of utility systems. This knowledge enables efficient identification, understanding of the location, type, and characteristics of utilities. But what do we do if we have incorrect as-builts or as-builts that are out of place? Here at LJB, we tend to lean towards field verification. We conduct a thorough field verification process to physically inspect the utility infrastructure. This involves comparing the actual layout and location of the utilities with the existing as-built documents. And we do this through utility locating technologies. So at LJB, we employ modern utility locating technologies such as ground penetrating radar and LiDAR. These tools can help identify the precise location, depth, type of utilities, allowing for more accurate and updated documentation. Finally, collaboration and knowledge sharing with the organization. We engage with utility organizations, local authorities, and other stakeholders to gather additional information and insights about the utility infrastructure. Collaborative efforts and knowledge sharing can help fill gaps in the as-built records and provide a more comprehensive understanding of the utility's locations and characteristics. So by combining these approaches, it's possible to supplement incorrect as-built records and correct assets out of place to ensure that the utility infrastructure information is more accurate, reliable, and up-to-date. Now, my coworker, James, will talk to you guys about how we go about.
Awesome. Thanks, Ivan. Hello, everyone. My name is James Bell. I'm here to talk to you about GPSing and our communication with our clients. You can see here a picture of me out in the field with our GPS and our iPad just a little bit out of frame below. Depending on the survey area for that given day, I can collect around 300 points for a full 8-hour workday. These points are collected at sub-foot accuracy, but that obviously just depends on the scope of the project. I have two methods for GPSing, depending on if reference maps are available from the city. I kind of let the survey revolve around knowing the general location of these features. However, if a city does not have that information, I must spend more time in the survey area to make sure I find all the assets. Regardless of the two methods I mentioned, this process is incredibly quick and efficient. So far, we have moved faster than scheduled for these projects. It's allowed me to move forward in other phases of these projects and continue the ball. There are challenges to this service, however. The biggest challenge would be the fact that this service is time consuming. We do tailor our services, so if a city wants to spend their own time GPSing their features, they can. It's important to note, though, that some cities can't allocate a city worker to spend the time GPSing like we can at LJB. The next challenge for GPS is obviously interference. Most of the time, this isn't an issue. If you find yourself under intense tree cover or near tall buildings, the GPS will start to stumble in terms of accuracy. So on the next slide, I want to talk to you guys about coordinating with the city. I communicate daily with city officials. Most of the time, I'm sending emails to the head engineer, the city telling them where I'll be for that particular day. Sometimes the city likes to surprise me in the field to say hi or just talk about progress. Another part of our communication with the city is coordinating with high traffic support. When the weather becomes more consistent and better, we shoot for at least one day of high traffic support throughout the week. That just helps us stay on track and continue our project or progress with the projects. The last thing we do at the city is acquire as-builts. This is important for digitization. Once we're done GPSing an area, we need the most up-to-date as-builts to start this process. This process consists of georeferencing drawings, the GPS points, then filling in attribute data from the as-builts. This information consists of like material type, pipe length, pipe slope, etc. This just ensures that the most up-to-date information is put in the utility network. On the next slide, the final topic I want to dive into is transparency through our apps. We use real-time web applications to allow our clients to check our progress in real time, meaning that if I'm out in the field, the city could follow along as I GPS an area. Another thing we do is create a map that shows areas that have been completed for both GPSing and digitization. This helps the city get a better understanding of our progress. On the next slide, you can see an example of this. We have a ArcGIS web app that shows completed areas. For this example in particular, any of the completed areas will be yellow, and obviously the symbology can change depending on client needs. But all right, I think that's all I got for you guys. Lucas is now going to dive into what happens after we collect this data.
All right, thanks, James. I'll take a deep breath for you. My name is Lucas Hershberger. I'm here to talk about how we go from collecting data in the field to presenting that data in an easy to understand and useful way in our apps. This is helpful for both internal and external consumers, whether you're an organization or something that's public facing. Our main field collection method, that, as James mentioned, was Field Maps Mobile, and Field Maps is a newer software than Server 123, but Esri continues to improve Field Maps capabilities. In my opinion, it's a sleeker form that you can set up right from within the new map viewer. So it saves time and requires less training to build compared to Server 123 Connect. Server 123 Connect still is unique in that it allows you to ask questions with multiple answer capabilities. So we definitely still use both, but Field Maps is the way we're trending right now. It can be used online or offline in case you're in an area with bad service or inside buildings. You can pre-populate fields based on related features or tables or physical geography. So for example, we can design a leak point on a water main so that when it's placed on a line by a field worker, it will automatically absorb through that geographic intersection what the material and diameter of pipe that the leak happened on. This speeds up field assessments so workers don't have to fill out excess rows or bounce back and forth between different layers trying to transfer information between them. You can maintain a history of inspections and repairs with related tables or unique feature layers. And it allows data collected in the field to be seen and reviewed immediately. So if James is out collecting points, I can be back in the office QAing that data at the same time. On the next slide, I will talk about dashboards. If the data being collected in the field is tied to an active or published data set, all of that information will then also be reflected immediately in web maps and dashboards. Dashboards are a great way to analyze large data sets with lots of feature layers and information. Maps can be present or not shown at all if you prefer to summarize your data with just charts, lists, and count boxes. And filters can be applied to modify not just the map, but all of those charts and graphs as well. And vice versa, you can customize charts so that when you click on them, it will filter the map and the graphics that are present. It really gives you the ability to dig down in your data. All those filters, they can work on top of each other. So I can have all four on to really to look at a small subset of data, or just one or two if I wanted to look at just manholes in one development, for example. On the next slide, dashboards can then be embedded in experience builders for extra functionality. Dashboards are great for understanding your data, so it's really helpful to have the ability to reference it in the same application that allows you to make decisions regarding that data. Experience Builder can host dashboards, web maps, 3D scenes, tables, really everything. And it will need to, because Experience Builder is set to replace the web app builder in Esri's suite of products. That's estimated to happen, I think, in July 2024. One of the coolest capabilities of Experience Builder is its pages design. So instead of having one web map that you log into and try to do everything on, Experience Builder allows you to combine different applications into one interconnected app. So have a dashboard on the first page to help users understand data graphically, then have a 3D scene on page 2 to help users understand the data geospatially. Then on a third page that is customized to perform edits on the data itself. They can all be tied together so that, for example, when you zoom in on the 3D scene and identify an asset you'd like to edit, those coordinates and zoom extent are reflected on the other pages as well when you go to perform your edits. And editing with Experience Builder is also a more user-friendly way to obtain GIS data from non-GIS analysts or members of the public. You can build the web maps and widgets to cater towards specific layers and fields. It allows you to obtain feedback without risking input errors or users seeing more information than they need to do the job that they're trying to do. And I'm sure a lot of you saw the Experience Builder yesterday, but the Experience Builder session that kicked off yesterday, but that was, I'm repeating some of their mentions, but that was a really, really great one to go back and watch if you are new to Experience Builder. On the next slide, Kelly, Experience Builder also offers the utility network trace widget. And I haven't touched on that earlier when speaking on the trace network analysis. It does require a license extension, but it is not limited to just ArcGIS Pro. Like Experience Builder allows you to perform that analysis in the application as well, which is really cool. So from Field Maps Mobile to the apps to the apps just for view to apps where you can actually edit your data. That's kind of a way that we get all of the Esri suite to work together to build us a really cool utility network management system. And that summarizes our presentation. I think now we can open up the floor to questions.